which it contains, see, normally the specific hypothesis which it contains some of the constraints, that we can call it as specific hypothesis. We are going to study in the concept learning. The first one is general hypothesis, which is identified by question mark. Question mark, what it indicates? The question mark which it indicates that the any condition which is acceptable. And the second one is a specific hypothesis. Specific hypothesis constraints. That what we can call it as the specific hypothesis. Yesterday we had a discussion related to FindS algorithm. See, yesterday we had a discussion related to FindS algorithm. See, now we are studying what the related to concept learning. In this, the concept learning, the two things will come. One is general hypothesis. Second one is a specific hypothesis. Understood? Here in the concept learning, the two things will come. The first one is general hypothesis. The general hypothesis, which is represented by question mark. Second is specific hypothesis. 5. Understood? Now, in this, the concept learning, we are studying the two algorithm. The first one is FindS algorithm. Second one is candidate. In the concept learning, we are studying the two algorithm. The first one is the FindS algorithm. Second one is what? Candidate elimination algorithm. FindS algorithm means what? FindS algorithm means we are checking only most specific hypothesis. Okay. In the FindS algorithm, we are finding the specific hypothesis. Specific hypothesis, call it as positive hypothesis or the positive things which it is represented by question mark, and specific hypothesis which is represented by negative. Understood? See, you can look at this table. In this table, these 1, 2, 3, 4, these are the what we can call it as the instances. Here the 6 attributes we are considering. What are the 6 attributes? Sky, air temperature, humidity, wind, water, forecast. Okay, these we can call it as attributes, and the attributes having some of the values. Sky having, these are the values, sunny, rainy, these are the values of the sky. Air temperature. Okay, see the first instances, the sky. See these we can call it as sky, warm, normal, strong, warm, same it is there. These we can call it as what? The values. Sky, air temperature, humidity, wind, water, forecast. We can call it as attributes. 1, 2, 3, 4. We can call it as what? Instances. I hope you understood. Okay. These are the what? The instances, attributes, and next one is what? The values, that is. See now. Now, see. Now we are studying which algorithm? FindS algorithm. There are the two algorithms. It will come in the concept learning concept. What are the two algorithms? The first algorithm is FindS algorithm. Second algorithm is candidate elimination algorithm. In the concept learning, the two things is very important: general hypothesis and specific hypothesis. General hypothesis, which is represented by question mark, and the specific hypothesis, which is represented by what? 5. General hypothesis, there are the two hypotheses: general hypothesis, specific hypothesis. General hypothesis represented by question mark, specific hypothesis represented by null. General hypothesis means the FindS algorithm, it evaluates only, it consider only positive examples. FindS algorithm, it consider only positive examples. See, look at here, look at this table. In this table, enjoy sport is there. When the what? The person, when the John or when some of the person, when he enjoy the sports, when only the sunny, warm, the first, second, and fourth instance. In this fourth instance, in these the 3 instances, he is enjoying the sport. But in the third instance, he can't enjoy the sports. FindS algorithm, what it is going to do? FindS algorithm, it is going to check only with the positive results. It is going to check with only the what? The specific hypothesis. Understood? FindS algorithm, it checks only the positive, the what we can call as the values, positive examples. We can apply the FindS algorithm only for the positive cases. Yes, here S is there, means this is the positive case. We can apply the what the FindS algorithm. In the second instances, positive yes is there, means it is a positive. Yes, here we can apply the FindS algorithm. In the third instances, no, it is there. Here we can't apply the what the which one we can't apply the FindS algorithm. The fourth instances, yes is there, there is a positive. Here we can apply the what the FindS algorithm. See, in this table we can represent that we are considering the four instances. Out of four instances, we can apply the what the FindS algorithm only for the what the three instances. Understood here? This is the concept of the FindS algorithm. See now, the x1 as an instance. What are the x1? Sunny, warm, normal, strong, warm, same. This is what positive instance. Here I mentioned what positive. Positive means what? According to this table, yes is there. So I can evaluate this in the FindS algorithm. FindS algorithm, what it is going to say? See, this is the x1 and the h1. X1 same as it is with the h1 here. Okay. Next, what I'm going to do here, please look at carefully. X1 it is here, and we have to compare with the x2. Look at carefully. Once again, I'll repeat. Here I'm applying the which algorithm? I'm applying the FindS algorithm. FindS algorithm, it is a concept learning technique. FindS algorithm we are using for most specific hypothesis. And again, FindS algorithm we can evaluate only for the what the positive examples. We can evaluate only with the what the positive examples. That is what the FindS algorithm. I'll repeat once again. FindS algorithm we are using only for the positive examples. According to this table, three the three one first, second, and fourth. These we can call it as a what the positive, and the third entity we can call it as a what the negative. Why it is positive here? Because the person he enjoy the sports, so we can consider as a what he is enjoying. That's a what we can call as a positive here. The first instance is positive. Now what I'm going to do, I'm applying the which algorithm? I'm applying the FindS algorithm. How I am applying the FindS algorithm? X1 and x2 it is the here. Here also I am considering the x2. Sunny, same. The same thing what which I consider here as a x2. Now I am preparing the h2. H2 means what? Second hypothesis. See, the FindS algorithm we are checking only with the what? The specific hypothesis. Now I'll write h2. H2 here how I am writing? Compare with the x1 and x2. Depending on x1 and x2, I am writing the what? h2. H1, H which it represents hypothesis, X which it represents what? That's a what are the entities, or we can call it as the what.
Sir, voice ಇಲ್ಲ sir.
Are you getting my voice? Hifzul? Pratiksh?
ಸರ್ ಮಧ್ಯ ಮಧ್ಯ ಬರುತ್ತೆ ಸರ್ ವಾಯ್ಸ್ ಹೋಗುತ್ತೆ ಸರ್.
Okay, here I'm facing some other networks issues, that's why. But ಬೇರೆಯವ್ರಿಗೆಲ್ಲ ಏನು ಈಗ ಇಲ್ಲಿ ತನಕ ಹೇಳಿದ್ ಗೊತ್ತಾಯ್ತಲ್ಲ? Fine. How many?
ಒಂದ್ ನಿಮಿಷ
37
ವಾಯ್ಸ್ ಇರ್ಲಿಲ್ಲ ಸರ್.
ಮಧ್ಯ ಈಗ ಒಂದ್ ಸ್ವಲ್ಪ ಬ್ರೇಕ್ ಆಗಿತ್ತು. ಓಕೆ, ಅಗೇನ್ ಐಲ್ ರಿಪೀಟ್ ಒನ್ಸ್ ಅಗೇನ್.
ಈಗ ಕೇಳ್ತಿದ್ದೆ ಸರ್.
ಕೇಳ್ತಿದೆಯಲ್ಲ? ವೇಟ್ ಒನ್ ಸೆಕೆಂಡ್, ಐಲ್ ಪ್ರೆಸೆಂಟ್ ಒನ್ ಸೆಕೆಂಡ್. Today I'm facing some the network issue, especially with the Airtel. Fine. See here, x1 and x2. Depending on the x1 and x2, I'm writing the h2. So x1 and x2 is what? These are the instances. Okay, x1 and the x2. So depending upon this x1 and x2, I'm writing the h2. Now you understood. See, if the x1 and x2, sun is there, I need to sun is same. The value of the one. But in the x1, the third value normal it is in the x1, and x2 it is high, it is there, but both having the positive value. That's why what I am doing here I mentioned the question mark. Question mark, what it indicates? The question mark which it indicates what? It is a general hypothesis, means whatever the value it is going to accept. Understood here? And see the next one. In the next value is the warm. Here also warm is there, so I'll write here warm. Here same it is there, here also same it is there, so I'll write as it is warm. Means whenever you are writing the hypothesis, first we have to compare with the two of the instances, x1 and the x2. Here the x1 and the x2, I'm comparing with the two instances. In the both the instances, the value it is same, then we have to write the same in the hypothesis too. Then the hypothesis we can mention as a what? We can mention the specific hypothesis. That we can call it as what? The question mark. Question mark which it indicates what? The positive values. Also the question mark which it indicates what we can call it as the any value it is going to acceptable, that is. That we can call it as a what? The question mark. I hope you understood how here the h2 it came. Any doubts? I hope everyone you know how to write the h2. Any doubts is here? This is the FindS algorithm. Any doubts in the FindS algorithm? Muzavir, Srilekha, Hifzul. I don't know where is Hifzul. From last 2 to 3 times I am asking. Any doubts? I hope you know how to write the the H2, H1 and H2. Any doubts? No. Fine. Then I'll move. See, with the same. See, I'm writing. I'll consider for the what? The H3. See, first instances, second instances I done already. Third instances I am not going to touch, because third instances it is not possible. Why the third instance is not possible? Third instance it is not possible because the third instance which is having the what? The negative value. So I can't apply the which rule? I can't apply the FindS rule. So now I'll go to the what? The fourth one, because for the fourth one I can apply the FindS algorithm, because which is having the positive results. Understood here how this is? Okay, fine. See now. I'll go to the next slide again. See, x1 and x2 is there. Depending upon this x1 and x2, I'll return h2, means hypothesis. Next, I'm not going to touch x3. Why? Because in the x3 what is there? The negative result is there. So that's why I'm not going to write here. Okay, so it is not possible here. See, upon the encountering the third training algorithm makes no change to h, because the FindS algorithm simply ignores the every negative example. See, according to the FindS the algorithm, here we are going to neglect the what? The negative example. But I'm going to go with the x4. So x4 I'm going to check with the x1. So depending upon the x1 and x4, I'm writing the what? H4. Understood here? See now, I'll compare with the x1 and x4. In the x1 Sunny is there. So here I'll write the first value Sunny as it is. Second value in the instance x1 warm is there. Second value in the x4 warm is there. So I'll write as it is. So third value in the x1 normal is there. Third value in the x4 high it is there. normal and high, both are different values. So I written here what I wrote here. I'll return the question mark here. Next, strong is there. So I'll write as it is, because in the both the entity, both the what the x1 and x4, which is having the same values. So I'll mention as it is. Here warm, cool is there. So both the value it is different. That's why which I mentioned question mark. Question mark which it indicates what? Specific hypothesis. Now, same and change is there. So he'll write in the general hypothesis. Okay, the question mark which it indicates the general. Question mark which it indicates the what? The general hypothesis. Null which it indicates the what? Specific hypothesis. Please keep it in your mind. Question mark which it indicates what? The general hypothesis, and whatever the same value which is represented by the what? The specific hypothesis. Now, same change is there. So here I mentioned the question mark. I hope why I written here question mark, why I return the any doubts with the FindS algorithm? You have any doubts, or shall I repeat once again? Could you type in the chat box? Have any doubts? Okay. Pratiksh is there? Pratiksh, Muzavir, unmute the mic.
Yes, sir. Hello.
Okay, fine. I'll go to the next concept. See, this is the what we can call it as the FindS algorithm. Okay, next. See, depending upon the FindS algorithm, we are preparing here instance as well as the hypothesis. See now, see here we can check out here H0, H1, H2, H3, and the H4. See what it is going to represent. See, this is the instance X as well as the hypothesis H. See here, the H1, H0 and H1, which is having the more specific, but H2 and H3, it is not that much specific, and H4, it is a general. See, according to this diagram, what it is going to represent, which it is going to represent, if we are having the four hypotheses, out of the four hypotheses, H0, H1, and H2, H3, it is more specific compared to the what? The H4. H4 it is a general compared to the what? The remaining hypothesis. So these what we can call it as the FindS algorithm. FindS algorithm, what it is going to do? FindS algorithm, it is going to check it out with the what? The specific values. It is going to check it out with the what? General to specific. Okay. So it is going to check out with the what? The general to specific of the values, that we can call it as the FindS algorithm. Next. I'll move towards the key property of FindS algorithm. What is the property of the FindS algorithm? The main property of the FindS algorithm is the FindS is guaranteed to the output the most specific hypothesis within H that it is consistent with the positive training of the examples. See here the main thing of the what we can put, the main thing of the FindS algorithm, it is guaranteed to the output most specific hypothesis. We can give the guarantee here, so we'll get the specific hypothesis. FindS algorithm, finally hypothesis will also be consistent with the negative examples provided with the correct target concept is contained in the hypothesis H and provided the training examples are correct. These are the key properties of FindS algorithm. Next. Unanswered by the FindS. What are the drawback of the FindS algorithm? See, the main drawback of the FindS algorithm is FindS algorithm, it is going to evaluate with only the positive example. That is one of the big disadvantages of the FindS algorithm. See, normally the questions will come. What's the meaning of the FindS algorithm? FindS algorithm, it is a concept learning algorithm. In the FindS algorithm, we are going to check it out with the what? The most specific hypothesis. General to specific hypothesis, we are going to check it out. Specific to general, we are going to find out in the FindS algorithm. But what is the we can't check with the negative example. It is only checking with the evaluating with the positive example. That we can call it as the FindS algorithm. That is one of the main drawback of FindS algorithm. FindS has the learner converged to the correct target concept. Why prefer the most specific hypothesis? Are the training example consistent? No. What if there are the several maximally specific consistent hypotheses? So we can't answer for these four of the questions. That's why the FindS algorithm, which is the suffering from some of the what the problems. What is the main problem? The main problem in the FindS, it is suffering from what it can't evaluate what the negative examples. It can evaluate, but it will take what the more what we can call it as the training the examples we should provide here. That is one of the what the main drawback of the FindS algorithm. So for resolving the FindS algorithm, yes, we know the meaning of the FindS algorithm. FindS algorithm means what? It is a what the most it is going to find out the specific hypothesis. The positive examples we can move specific to the general hypothesis, and the FindS algorithm it evaluate only with the positive example, but it is not going to evaluate the negative example. That's why we move. So whatever the previous of the what the unanswered by the FindS is there, which is which have the some of the solution which is represented by in the version space, or we can call it as the candidate elimination algorithm. So the next concept, version space and candidate examination algorithm. Any doubt in the FindS algorithm, you can ask. If you have any doubts in the FindS algorithm, you can ask. Anybody having doubts? The FindS algorithm? Anybody having doubts in the FindS algorithm? Okay, then I'll go it as it is. Fine. Then next I'll move towards the version space. What's the meaning of the version space and candidate elimination algorithm? See the name only which it indicates version space. We need to provide some of the word the space. And next one is the word the candidate elimination algorithm. The key
Sir,
idea in the candidate elimination
sir,
algorithm. Yes.
sir,
Yes, please. Huh.
it's a prayer time, sir.
At what time
So we
now?
need break, sir.
How much time you need break?
Now,
At what time your the prayer time is?
10.
Hello.
Now,
Now it is there.
hello.
Okay.
It's now, sir.
Okay. Okay.
Yeah.
Okay. Then you leave. It means those who are having the prayer time you can leave. So for the remaining I'll explain. Then afterwards once again I'll explain. We'll see. Okay. Fine.
Attendance.
Attendance. I'll consider those who are going. No, just to message. Please drop a message. So I'll check it out. Now I'm taking. Wait. 1 second. Wait. I'll take the attendance with the spreadsheet. Wait.
Okay. Thank you, sir.
Fine. Those who are having, you can leave. So just I'll explain the theory concept. So I'll finish within 10 to 15 minutes. Okay. Then next week I'll explain. Now, the version space and candidate elimination algorithm. What's the meaning of the version space and the candidate elimination algorithm? The key idea in the candidate elimination algorithm is to the output description of the set of all hypotheses constrained with the training example. See, here the candidate elimination algorithm which is evaluated both the positive as well as the what the negative examples depending upon the what the consistent with the training example, whatever the training example, the consistent training example you are giving, depending on that what it is going to evaluate the what the output description, that what we can call it as the candidate elimination algorithm. Saying in the concept learning, the two algorithms will come. The first one is which algorithm? The first one it is a FindS algorithm. The second one is what? The algorithm. The definition for the candidate elimination algorithm. A hypothesis H, it is a consistent with the set of training example D. C, H which it is indicates hypothesis, D which it indicates what the examples. If and only if H of X is equal to C of X. H of X means what? Hypothesis. C of X is equal to means what? The target value. Understood here? That's why H of X is equal to C of X. In the consistent with the what? D. Here D which is represented by the example, H which it is indicates what? The hypothesis, C which it indicates what? Sorry, the target value. So the like this here we can represent here. H of X is equal to C of X. Here in the candidate elimination algorithm, the one more thing we are defining here, that is a D. D means what? It's a set of training example D. Okay, it's a what? The set of example, it is a D. Note the difference between the definition of the consistent and satisfies. See here, the two things is very important. The first one is the consistent. Second one is what? The satisfies. An example, X is set to satisfy, then H of X is equal to 1. When H of X is equal to 1, which it is satisfied. Okay, an example, X is set to consistent, then H of X is equal to C of X. H of X is equal to 1. H of X is equal to positive. Hypothesis of the what? The particular, the target value, it is a what? The 1. H of X is equal to 1 means which satisfies. C of X is equal to, and next one is when it is going to consistent, the consistent only if and only if H of X is equal to C of X. See, in this, the candidate elimination algorithm, we should differentiate between the two things or the two definition. The first one is the consistent and the second thing is what? Satisfies. When we can say the candidate algorithm, it is consistent, only if H of X is equal to 1, we can say it is a satisfy. And when it is a what? The consistent, if H of X is equal to C of X. Satisfy or whether it is consistent. Okay, this is the representation of what? The candidate elimination algorithm or the version space and candidate elimination algorithm. Next, see, version space, a representation of the set of all the hypotheses which are consistent with D. See, representation of the set of all the hypotheses which are consistent with D. D means what? How many examples, how many trained sets you are considered, that we can call it as D. Then what is the definition of the version space? The definition of version space is the version space which is denoted by VS H comma D. Capital VS which is represented by version space, H which is represented by hypothesis, D which is represented by what? The training examples. Understood here? So version space we are defining by VS H D. VS which is represented by version space, H which is represented by hypothesis, D which is represented by what? The training examples. It is a subset of the hypothesis from the H consistent with the training examples in the D. So that's why VS H comma D, that is H belongs to H only when it is consistent with the H comma D. When it is consistent, it is consistent only what? H of X is equal to C of X. When it is satisfied, if H of X is equal to 1, so we can call it as satisfied. When H of X is equal to C of X, we can consider it is a what? The consistent. Now the next is what? The version space. What's the meaning of the version space? The version space we can define by VSHD. VS which is represented by version space, H which is represented by hypothesis space, D which is represented by what? The trained examples. That what we can put as the D here. So that's why VS H comma D, that we can put as version space. Now you can see hypothesis space. There's a what? The H. Hypothesis means whether it's a general, whether it's a what? The specific. That we need to find out. General to specific or specific to general. There's a what we can call it as hypothesis space. Next, examples. Examples means what? Set or the what we can call as the trained settings, that trained sets, that we can call it as the example. So combining with the both training set plus hypothesis, then we can identify the what? The version space. So this is the what? The pictorial representation of version space. Understood? I'll repeat once again. The version space which is represented by VSH comma D, where VS, which is represented by version space, H, which is represented by hypothesis, and D, which is represented by what? The data sets. Okay, trained data sets, we can call it as. So now this is the pictorial representation. The left hand side, we can look at the hypothesis.
Sir, your voice is not audible.
ये network apart. Okay, the candidate elimination of the algorithm, the least and then eliminate the algorithm. Okay, fine. Today I'm facing some internet issues. So I'll stop here only. So next class onwards, I'll explain the candidate elimination algorithm. Any doubts? Till now, any doubts? You are having any doubts, you can ask. Then I'll take the attendance else. So here I'll stop the session. Today's session I'm going to stop. Then I'll take the attendance. Okay, Aditi. Aditi.
Present, sir.
Absent.
Present, sir.
Fine. Aditi, present.
Present, sir.
Present. Okay, fine. Next, Afnan. Afnan. Afnan absent. Next, Fayaz absent. Yeah. Okay. Okay. Aishwarya Naik.
Present, sir.
Aishwarya Naik.
Present, sir.
Absent.
Present.
Aishwarya Naik. Okay.
Present, sir.
Aishwarya Augustine.
Present, sir.
Aishwarya Augustine.
Present, sir.
Okay. Aishwarya K. Aishwarya K. Aishwarya K present.
Present,
Augustine
sir.
present. Aishwarya K. Aishwarya K. Present. Okay. Next. Afzal Abbas.
Present, sir.
Afzal Abbas.